Algebra Honors, this is our review for our final. So this review is very comprehensive, and your final exam will actually only have 25 questions. So you have many opportunities for practice on this review, and you will have 25 questions on the actual final. And you can create a formula sheet to bring with you to that final. So anytime you're working on something, if you either are working and you need to look up a formula or you need to look up a quick reminder about how to do something, make a note of that because that's stuff that you might want to put on your formula sheet. All right, so we're going to simplify this. This is the cube root of 5,832 x to the 9th y to the 5th. So I'm going to tell you that in general, if you have a cube root or a square root of a big number, go ahead and double check. See if it happens to be a perfect, in this case, a perfect cube. So I have 5,832. I want to know if it's a perfect cube, so I'm going to take the cube root on the calculator. On this kind of a calculator, I'm actually going to be using the second function on the 0. That actually is hard to see, but you can. It's a cube root of x right there. So I'm going to press second function and the 0, and it's going to find the cube root of my number. It says the cube root of 5,832 is 18. So great. That means that I don't have to break down 5,832. I know then that this equals 18 times the cube root of what I have left, which is my variables, x to the 9th, y to the 5th. Now, there are other ways that you could have done this. If you didn't have a calculator that showed you where the cube root was, you can break 5,832 down. You can just factor it. So 5,832, if you want to factor it, it's obviously even, so 2 goes into 5,832. 2 goes into 5, 2 times, 18, 9 times, 3, 1 time, and 12. Okay, and then you just keep doing that. That's even again. So you can do 2 goes into 2, 1 time, 2 goes into 9, 4 times, 11, 5 times, and 16, 8. It's even again. So 2 goes into 14, 7, 2, 9. It's no longer even, but I'm pretty sure that's divisible by 3. So now I'm going to say 3. 3 goes into 7 2 times, and 3 goes into 12 4 times, and 9 3 times. And I'm going to keep doing this. So I have 81. 81 I know is a perfect square, but I'm looking for cubes, right? So 3 goes into 81, 3 goes into 8 2 times, and 21, 7, 3, and 3 times 9. Can you still see my numbers? Sorry, no, not quite. 9 is 3 times 3. Okay, so I have done a factoring tree. I found the prime factorization of 5,832. Now, because I have cube roots, I'm looking for triples, right? So I have triples here, and then I have triples here, and then I have triples here. So I take each one of those triples outside of the radical. So I'm going to pull out all 3 of these 2's, and as soon as they're outside of the radical, I just have one of them, right? The cube root of 2 times 2 times 2 is just 2. I do that again. The cube root of 3 times 3 times 3 is 3. I do that again because I have another triple. So 2 times 3 is 6, and 6 times 3 is 18. That is how we got to 18 if we had to do it manually. All right, so now I need to break up x to the 9th and y to the 5th. So remember, the way we do this, our method is we take the exponent and divide by the index. Okay, so this is going to be 18 times x to the 9th. 9 divided by 3 is 3, so it's going to be x to the 3rd. And then I have y to the 5th. 5 divided by 3 is just 1, so I have y. And 5 minus 3, the thing I'm left with, is y squared. Okay, so this is actually my final answer. If you want to see this done differently, we've already pulled our 18 out. So this is just looking at it differently. And I have the cube root of, I have x to the 3 times x to the 3 times x to the 3, right? 3 plus 3 is 6, plus 3 more is 9. And then I have times y to the 3 times y squared. That would be y to the 3rd times y squared, y to the, you keep your base and you add the exponents. So here you can say I'm going to pull out a triplet. I'm going to have 18x to the 3rd And then here, I'm going to just pull out y to the third and take the cube root of that. So I just have the cube root of y to the third is y, and then I would have the cube root of y squared. Same answer, 18x cubed y times the cube root of y squared. Oh, I'm sorry, you couldn't see my 18s over there. Okay, so several different methods to get here, but definitely if you have access to a calculator, check and see if you have a perfect cube, or if you divide it by 2. If it's not a perfect cube, try dividing it by 2 and see if the bigger number is, and so on. Okay, we're going to look at number 2 now, and we're going to simplify this. Again, there are several ways to do this. I'm going to make my exponents all be positive. Okay, so 4 squared, all raised to the power of -1, that's going to be 4 to the 2 times -1 is -2, times m, times n to the -3. I'm just doing kind of one step at a time. 2 to the -3. I've got m to the 0 is 1, right? So I don't need that. And I have n to the -1. All I took care of was that outer exponent. So now I'm going to move things around. And if I have a negative exponent, I'm going to make it a positive exponent. This guy's going to go down. Okay, so I have 4 squared. This guy's going to go up, so I have 2 to the third. M has a +1 exponent, so m is going to stay right where it is. N to the -3 is going to go down, right? Now it's n to the third, and n to the -1 is going to go up. So now it's n to the 1 and going up. Okay, now I need to simplify. Okay, so what I'm going to do is I know 2 to the third, 2 times 2 is 4, times 2 again is 8. So my new fraction has 8. 4 squared is 16. So I've taken care of my numbers. I'll deal with simplifying that fraction. M is the only m that I have, so I'm just going to keep m. And then I have n to the 1 over n to the third. So remember, we actually are going to take the difference. 3 minus 1 is 2. My new exponent is going to be 2. So I need n squared. And I'm going to put n squared wherever the bigger exponent was. So n squared is going to stay below. Our algorithm said that we say n to the 1 minus 3. So we would get n to the -2. And then we would want to have only positive exponents. So we would move it to the denominator anyway. Okay, I'm nearly done, but I know I can simplify 8/16. So I have 1m over 2n squared. And that is my final answer. All right, so number 3, I'm going to simplify this. This one I'm also going to take care of that outer exponent first. Remember, it goes to every exponent you can find inside, okay, and we multiply those. So I have 3 to the 4 times x to the -3 times -2 is 6, y to the -10, and that's all over 9 to the 4, x to the 8, y to the 4. Okay, but I'm not done because I can definitely simplify this. I'm going to go ahead and do my, I could be really fancy here. I'm not going to. I'm going to say 3 to the 4th power on my calculator is 3. I do y to the x, 4, 81. X to the 6th over x to the 8th. You know I get to actually count that as x squared in the denominator, right? 8 minus 6 is 2, and I keep my answer wherever the bigger exponent was. So I've taken care of 3 to the 4th, I've taken care of my x's, and I have y to the -10 over y to the 4. Well, -10 minus 4 is going to be -14, so I would have y to the -14 up top, but I'm going to go ahead and put y to the 14th in the denominator. I kind of did 2 steps at one. I have not dealt with 9 to the 4th. 9 raised to the power of 4 is 6561. Okay, I am going to see if 81 divides into that evenly, so I'm going to divide by 81 to simplify. And it does, so yay, 81 goes into 81 one time, 81 goes into 6561 81 times. All right, so my answer is going to be 1 over 81 x squared y to the 14th. Okay, that is not the only way to do that problem. That's just how I probably would have done it. You could also have moved this y to the negative 10 down to the bottom, and then y to the 10 times y to the 4 is y to the 14. A couple different ways to do that, but hopefully between my video here and Miss Shin's key, you'll be able to work your way through. All right, simplify. So I'm going to simplify, and if I look up at the directions, it says simplify the expressions to their simplest form. I'm going to leave this in radical form, though, instead of a decimal form. Okay, so this is square root, not cube root. So I need the square root of 60x to the 5th, y to the 8th. Remember, if you have an even exponent, it is a perfect square. So I'm going to break this up. I'm going to do this with a different method a little bit. 60, I know that that's 2 times 30, but that doesn't really help. Does 4 go in? 4 times 15 sounds good, right? So I'm going to change this so that it's 4 times 15, because 4 is a perfect square. I'm going to make x to the 5th be x to the 4th times x, right? Because you keep your base and you add. Now I have a perfect square hanging out. And then I'm going to keep y to the 8th just like it is, because I can now see some perfect squares. Perfect squares I can take the square root of. So the perfect square 4, if I take the square root of 4, it's 2. If I take the square root of x to the 4th, it's x squared. If I take the square root of y to the 8th, it's y to the 4th. You divide that outer exponent, or divide their exponent by your index, which is 2 here. Okay, I'm left with a 15 and an x inside my square root bar, so I keep the 15x in there, and that should be my final answer. Okay, if you needed to break down the 60 manually and find the pairs of numbers, because you want pairs because your index is an invisible 2, 60 is even, so I'm going to say it's 2 times 30. 30 is even, so I'm going to say it's 2 times 15, and I know 15 is 3 times 5. I have a pair, so I would pull that pair out, so I would have 2 on the outside of my radical, and then I would have 3 times 5 on the inside of my radical. So just finding the square root of 60, I would get 2 roots of 15. Okay, that's what we have, 2 roots of 15, and then we had to deal with our variables. All right, so 2x squared y to the 4th times the square root of x, 15x, sorry. Next, we're going to simplify. Remember, if we have a square root over a square root, we have some options. We can say that that's all the same fraction. So if I wanted to, I could simplify that fraction like that. Okay, or I could, alternatively, I can break this up. So I know the square root of 32 is 16 times 2, right? 32 is 16 times 2. And I know 45 is 9 times 5. So you have a couple different ways that you can do this problem. Probably I would do this so that I can pull out my perfect squares. I have 4 times the square root of 2 over 3 times the square root of 5. Now that is true, but we don't like to leave radicals in the denominator, right? So to get rid of the radical in the denominator, I'm going to multiply by square root of 5 over square root of 5. Right? Because I'm really multiplying by 1. I'm not changing the amount. Here, 4 times square root of 2 times square root of 5. Remember, if they are both square roots, I can multiply them together. So I have 4 times the square root of 10 in my numerator. My denominator, I have 3 times the square root of 5 times the square root of 5. Square root of 5 times square root of 5 is 5, right? So I now have 3 times 5 in my denominator. And if I want to simplify that all the way, it's 4 times the square root of 10 over 15. And I can't do anything more to that. Okay, so if you need to make a note on your formula sheet, a note or a reminder that you don't want to leave a radical in the denominator, do that. Okay, put yourself a big star so that you remember to rationalize the denominator. That's what that's called. Okay, simplify. We're going to keep all of our bunnies and kittens happy and safe, and we're just going to rewrite this so that we don't make a careless error. This means 3x plus 2 times 3x plus 2. Be careful here, okay? Don't rush. FOIL, 3x times 3x is 9x squared. outer is 6x, inner is also 6x, and last is 2 times 2 is 4. Now I need to combine like terms, so I know this is 9x squared plus 12x plus 4. That is my answer. If you remember how to square a binomial without writing it out like FOIL, that's okay. Just make sure that you don't lose that middle term, right? Absolutely, this is not 9x squared plus 4. Absolutely, that's not the right answer. Okay, down here, we're going to simplify. All right, this is 6x to the 0, which means anything inside these parentheses is to the 0, which means that's just 1. 1 times all of that. I would do that first. Now, the way I treat this is everything inside gets that exponent. So this is really negative 4 to the negative 6 times x to the negative 2 to the negative 6 times y to the 9 to the negative 6. And I'm writing it that way because I want you to be sure this negative 4, it's really in the parentheses. So when I bring that negative 6, it goes to the whole negative 4. It's really important that this negative 4 is in parentheses here. Okay, so I am going to rewrite this so that I have all positive exponents. So I have 1 over negative 4 to the negative 6 is going to be negative 4 in parentheses to the positive 6. X to the negative 2 times negative 6, that's x to the 12. Right? Negative 6 times negative 2 is positive 12. Y to the 9 to the negative 6 is going to be y to the negative 54. So I'm going to put it down here as y to the 54. Wow, that's an ugly number. Okay, so this equals, my simplest thing that I can have up top is x to the 12th. Down here, negative 4 raised to the 6th power. It's an even, so I know that my answer is going to be a positive, not a negative. Okay, negative 4 to the 6th on your calculator. Here's how you do it. Get out of my glare. Put in negative 4, so you press 4 and make it negative. I am raising that negative 4 to the power of 6. Y to the x. 6 is the power I want. 4096 is my number. Okay, 4096 is if I multiply negative 4 times negative 4, 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 if I do that 6 times, okay? 4096, y to the 54. That's it. That crazy thing is my answer, x to the 12th over 4096, y to the 54. Okay, use your parentheses. All right, I can add and subtract radicals if they are the exact index and the exact number in the radical. So I'm going to simplify all of these. So I have 3 times the square root of 10. That's as good as I can get there. This is the square root of 3 times 25, right? Minus 2 times the square root of, I know that's 4 times 10. Minus 4 times the square root of, I know 12 is 4 times 3. So I've expanded it all the way out, and now I'm going to simplify my radicals. 3 times the square root of 10 is still the same. Here, I can pull out the square root of 25, so I have 5 times the square root of 3. Here, I already have 2, and I'm going to pull out 2. So 2 times the square root of 4 times 10 under the radical. It's going to pull the 2 out, so now I have negative 2 times 2 is negative 4 times the square root of 10. Minus, here I'm going to pull out the square root of 4, which is 2, so negative 4 times 2 is negative 8 times the square root of 3. Okay, we're going to combine like terms. So anything that is square root of 10, don't lose your negatives. 3 roots of 10 minus 4 roots of 10 leaves me with negative 1 times the square root of 10, negative 1 root of 10. And I have positive 5 roots of 3 minus 8 roots of 3. 5 minus 8 is negative 3 roots of 3. Okay, so that is my answer. All right. If I am multiplying, so this is distributive property, right? I'm going to have to multiply square root of 2 times this first term, and I'm going to have to multiply square root of 2 times the next term. So remember, if I'm multiplying square root of 2 times 9 times square root of 10, the things I can multiply together are those square roots, right? So this is going to keep 9 on the outside, and then square root of 2 times square root of 10 is square root of 20. Minus, now I have square root of 2 times 11 times square root of 8. So I have 11 times the square root of 2 times 8, which is 16. And of course, I always want to simplify. I can see that this is really 9 times the square root of 4 times 5 under the radical, minus 11 times 4, right? Because the square root of 16 is 4. I'm going to take out the square root of 4, that's 2. 9 times 2 is 18, and I'm left with square root of 5, minus 44. That's it now. I cannot go any further than that. I'm done, 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 okay? Now I can't combine them. All right. Number 10. Number 10, I have a monomial in the denominator. So that means that I can just simplify by dividing that denominator into every term in the numerator. Okay, so I'm going to say 18 divided by 6 is 3. X cubed divided by x is x. Plus 12x squared over 6x squared. 12 divided by 6 is 2. X squared divided by x squared is just 1, so I just have 2. Minus 3x divided by 6x squared. Well, 3x over 6x squared, I can simplify that, right? Because 3 goes into 3 one time and 3 goes into 6 two times. So one way I can write this answer is 3x plus 2 minus 1 over x squared. That's a little ugly. That is an answer. Another way I can do this is I see that each one of these terms up top and the term in the bottom, I can divide every single one by 3x. So I'm going to factor out 3x. Okay, so 3x times, this would be 6x squared plus 4x minus 1. Right, because I just pulled 3x out. And then I have 3x times 2x. Okay, now my 3x's cancel. So the other way I can write this answer is 6x squared plus 4x minus 1 all over 2x. Okay, so these are the same answer. These are the same answer here. I would accept either one of those. All right, 6x squared plus 4x minus 1 can't be factored, so I looked for two numbers that multiply to give me negative 6, but add to give me 4, and I couldn't do it. There was nothing to do, so I couldn't factor that anymore. So, okay. All right, let's do a couple more problems, and then we'll start a second video. This time, I have a trinomial in the denominator, I have a binomial in the numerator, so I know my best bet for something like this is to factor everything out and see what I can get to cancel. So I'm going to pull an x out of the top. I have x times x squared minus 1. And in the bottom, I'm going to pull out an x from everything. X times x squared minus 3x plus 2. Okay, so far so good? Let's cancel those x's. X divided by x is just 1. Now, I have a binomial and I have a trinomial. I see that this is a difference of squares. So I know that I can factor that numerator so that it's x plus 1 times x minus 1. So I am hoping that when I factor that bottom trinomial, I'm going to have either an x plus 1 or an x minus 1. Let's see. To factor x squared minus 3x plus 2, I need two numbers that multiply to give me 1 times 2, so that's 2, and they have to add to give me negative 3. Well, negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 3, so those are my factors. I'm lucky because my leading coefficient was 1, so that means I can just plop in my magic numbers from the x puzzle. So I have x minus 2 times x minus 1. I'm plugging in those two numbers. Now, is there anything I can cancel? Why, yes. Yes, there is. X minus 1 and x minus 1, because anything divided by itself is 1. So that means my answer would have to be x plus 1 over x minus 2. That is my answer all the way factored out. Okay, so simplify the next one. Now, notice that on this next one, I have a monomial in the denominator. So why don't we try factoring stuff out? Okay, I see that I could take a 3 out of everything in the top. I could take a y out of everything in the top. So let me go ahead and do that. I'm going to pull 3y. And I'm left with 4xy squared plus 4y minus 2 in my numerator. It's all over. I'm going to pull out 3y, and I'm left with negative 1. So that's a little messy, but we're going to do that anyway. Okay, 3y divided by 3y, that's 1. Now, let me go ahead and divide everything by negative 1. It's just going to change the sign of everything. So I have negative 4xy squared minus 4y plus 2. I'm doing that because I'd rather not have a fraction if I can help it, right? I just divided each term by negative 1. Now, let's see if I can factor that. I can pull out 2 or negative 2. Let's go ahead and pull out negative 2. Get a negative out of there. Negative 2 times 2xy squared plus 2y minus 1. Oof. Okay, well that's a lot. So, just for kicks, I'm going to see if I can by chance factor this. It's looking pretty sketchy though. If I needed two numbers that multiply to give me negative 2 but add to give me positive 2, well, to get negative 2, it's 1 times 2. It's either negative 1 times positive 2 or 1 times negative 2. And those don't work. It doesn't work. Okay, so this is it. That's what I'm going to do. Okay, I believe on the key we seem to have accepted that. I'd prefer simplifying. I'd probably prefer to pull out that negative 2, but we could accept either one of those answers. Actually, maybe I would leave it like that.